Hi, welcome to the class. Today we'll start another topic of chapter 2 of unit 2 current electricity, and the name of the topic is Wheatstone Bridge. So what do we mean by Wheatstone Bridge? So let me first tell you that Wheatstone Bridge is just a concept, okay, based on which we solve the problems related to the resistances connected in the form of a bridge. That is why we call it Wheatstone Bridge. So how do we solve it and what this concept is? So basically this concept says that you need to have four resistances connected in this form like P, Q, R, S. Four resistances connected in the form of a bridge. P, Q, R, S. Now these resistances when connected in the bridge are connected to a cell whose EMF is E with the help of a key, and in between these resistances a galvanometer is put up. To detect the presence of current. Galvanometer is a device which detects the presence of current, and also this galvanometer is put up with the help of a key K2. So this is what we call the Wheatstone bridge. It's a concept combination of four resistors connected in the form of a bridge, right? So this is the introduction to Wheatstone bridge. Now there is something called balancing condition of a Wheatstone bridge. So balancing condition of a Wheatstone bridge. So according to this balancing condition of a Wheatstone bridge, these resistors, four resistors which are put up in the form of a bridge, are put up in such a way that the galvanometer does not deflect. Or the galvanometer current, which is Ig is equals to 0. When this will be 0? When we will say this is the balancing condition of a Wheatstone bridge. It means Wheatstone bridge will be balanced only if galvanometer shows no deflection. That is, the current through the galvanometer is 0, right? So galvanometer shows no deflection and current. It means if the galvanometer does not show any deflection, it means that the current through the galvanometer is 0, and in that case this Wheatstone bridge is a balanced one. It means P upon Q is equals to R upon S. So this is what we mean by the balancing of the Wheatstone bridge. This is the condition for the balancing of a Wheatstone bridge, that the ratio of P by Q and the ratio of R by S has to be equal. Only then you will say that the Wheatstone bridge is balanced. And when this will happen? This will happen when the deflection through the galvanometer is 0. Galvanometer does not have any kind of current, right? So this is the balancing condition of Wheatstone bridge. Now if I have to prove this balancing condition of Wheatstone bridge, I am going to prove this using Kirchhoff's laws, and here I will use Kirchhoff's both laws. In the when we were solving the numericals of Kirchhoff laws, it was seen that the Kirchhoff's law, first law, was already being applied, and we were just to apply the second law. But here I will apply the first law, which is the current law or junction law, as well as the second law, that is the voltage law or loop law, right? So let us begin. So the current I is coming from the battery, from the cell. Current I is coming at this junction. What happens at the junction? Either the current meets or the current separated from each other. So at this junction the current will be separated from each other. So out of I1 goes there. From I1 goes there. So how much will be left? I minus I1. Now at this junction again, Ig, which is the galvanometer current, it goes in. So from if Ig goes in, how much is left? I1 minus Ig, right? Now this I minus I1 is coming. So again at this junction, what will happen? This Ig is coming downwards. This I minus I1 coming here. They meet at this point and they form something called I minus I1 plus Ig. Now at this junction, now guys you need to understand one thing. At this junction, before current gets separated away, the current was I. So when all these currents meet at this point, it has to be I. If it is I, it means the first law, Kirchhoff's law, that is junction law, which you have applied it correctly. If it is the same current, same means I here and I there. If it is not the same current, you should be aware that you have done some kind of mistake, right? So this was done. This I minus Ig is coming. Ig is coming at this junction. They both meet and they form I minus I1 plus Ig. Now at this point, these two current will meet. Okay, because this is coming from here and this is coming from here, so they will meet. So I1 plus I1 minus I1 cancels out. Minus Ig plus Ig cancels out. What is remaining? I1. So it means we have applied the first law correctly. So this is how the first law is being applied. Now applying the second law. So we will take two loops. Again, we will take two loops. So in loop, I am taking this loop A, B, D, A, B, D, A. Right? Now, when I taught you Kirchhoff's, I said start moving from the positive of the battery. Now, since there is no battery, so I will start moving in the direction of the current, either in this direction or in this direction, whatever you feel like. So I will go in this direction, I1 into P, because P is the resistance. I1 P. So this will be P I1. Then I go there. Ig is the current and G is the galvanometer. It also provides some resistance. So it will be Ig into G. Plus, why plus is coming? Because I am moving in the direction of current. So Ig into G. Then I will come here. I will move in this direction. So when I am moving in this direction, but current is coming in this direction, what should come? Minus or plus? So minus will come. Why minus? Because I am moving in the opposite direction of current. So I minus I1 into R. R is the resistance. R is equals to 0. This is the first equation. Right? Now again I take in loop. What is the loop? BCDB. BCDB. I'll start here. What current is going? I1 minus Ig multiplied by Q. So I1 minus Ig multiplied by Q. Then I started coming here. What will come? Plus or minus? Minus. Why minus? Because current is coming like this, but I am coming like this. How much is the current? I minus I1 plus Ig into S. And then I will go here. So when I go here, current is coming in. What will come? Minus Ig into G. Ig into G is equals to 0. This is second equation. Now we will use this condition that if the bridge is balanced, because we are deriving this condition, P upon Q is equals to R upon S, and this condition can be there only if current through galvanometer is 0. So I will apply this condition that when Wheatstone Bridge is balanced. So when Wheatstone Bridge is balanced, current through galvanometer is 0. So current through galvanometer is 0. That is Ig is equals to 0. I will put this condition in these two equations. So Ig is equals to 0 means this will be 0. Whole term will be 0. What I will be left with? I1p minus I minus I1 into R is equals to 0. This will be my third equation. Or if I can send it there to the other side. So I1P is equals to I minus I1 into R. This will be my third equation. Now again putting this condition here. So this will be 0 and here this Ig will be 0. So what will be left? And this Ig will be 0. Right? So this will be I1 into Q. I1 into Q, then minus I minus I1 into S. So I am sending it that side. So this minus will become positive. I minus I1 into S. So this is 4. Now I will divide 3 by 4. Third by 4. So when I divide it, I get I1 upon P upon I1 Q is equals to I minus I1 into R upon I minus I1 into S. This goes off, this goes off. So it will be P upon Q is equals to R upon S. So this condition has been proved, right? So this is how we prove the condition. So now let's begin by doing some numericals. Okay, so this is a question which is based on Wheatstone Bridge, and here you can see 4 resistors, 6 ohm, 9 ohm, 4 ohm and 6 ohm are connected in the form of a bridge, and a resistor 7 ohm is connected in the place of a galvanometer. And we are given the question that we have to find the equivalent resistance between points A and C, right? So the very first thing which I will be checking out is this, that whether this bridge is balanced or not. Now what do we mean by balance? Balancing means P, Q, R, S. So balancing condition was P upon Q is equals to R upon S. So if this condition is valid in this case, then what will happen? If this condition is valid in this case, then what will happen? There will be no current with this branch, because earlier we did galvanometer was placed here. So there was no current flowing through the galvanometer when this condition was valid, right? So let us check whether this condition is there or not. So P means 6, Q means 9, R means 4 and S means 6. 3 2 ja 3 3 2 2 2 3. So you can see here also 2 upon 3 and here also 2 upon 3. It means P upon Q is equals to R upon S is being satisfied. Now if it is satisfied, then what will happen? There will be no current here. Current won't go there. It means if the current I is coming like this, I is coming like this, at this junction, current will divide. Let us say I1 is going there. So from I1 is going there. So how much will go there now? I minus I1 will go there. Correct? Now I1 will go, 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 and at this point, current will not divide. Why? Because this condition is balanced, and when this condition is balanced, there is no current through this. The current will not go through this. Why it will not go through this? Because this condition is satisfied. And if you remember, whenever this condition is satisfied, there will be no current through the galvanometer, and in place of galvanometer we have put this 7 ohm resistor, right? So current, this I1 will not go, there won't be any separation of the current here. I1 will pass through this, right? Now this I minus I1 will come, I minus I1 will come, it will come up till this junction. Now no current is coming in this direction, so nothing will be added, so the same current will pass through this, I minus I1, right? Now what you can see, I1 is passing through this, I1 is passing through this. Same current is passing through P and Q. So how P and Q are connected? They are connected in series or parallel. And I minus I1 is passing through R, and I minus I1 is passing through S. So how these two are connected? So they are connected in series because the same current passes. Whenever the same current passes, they are connected in series. So P and Q, comma R and S are connected in series. Now the combination of these two and the combination of these two is they will be connected in parallel, right? So first of all, let us do for P and Q. So RPQ. So you know the formula P plus Q. So RPQ will be equal to P plus Q. How much is P? 6. It will be 6 plus 9 is equals to 15 ohm. Then R, this is RS, these two. So it will be R plus S. So RS will be equal to, how much is R? 4 plus 6. It will be 10 ohm. Now this RS and this RPQ will be connected in parallel. So total R will be given by 1 upon R is equals to 1 upon RPQ plus 1 upon RRS, right? So 1 upon R is equals to 1 upon 15 plus 1 upon 10. So what it will be? If I solve it directly, I can solve it directly also. It will be R is equals to this. I have reciprocated. You take the LCM and you solve. I hope that you people can do this much, right? So I am doing it directly. So it will be 150 upon 25. And if you multiply it, it will be like 6. So total resistance will be 6 ohm. So this would be your answer. Have a look first how we have done. So this would be your answer for this part. So the total resistance in this would be 6. And one more we'll do, but in the other one, I would like just to explain you the process and you will do it as a homework part. I'll tell you the answer, right? So, next comment. So here you can see the diagram. So we have P 2 ohm, Q 4 ohm, R 3 ohm and S is equals to X ohm. It means the value of S is not given. It is given as X. And there is a resistance in the branch AC in place of galvanometer, and the value of that resistance is 10 ohm, and they are saying it's given in the question that no current is passing through this, no current is entered. So when that is the case, when no current passes through this branch, we know that the bridge is balanced. So when the bridge is balanced, in the first part of the question they are asking you to calculate the value of S, which is X ohm. So that is the first part of the question. So when no current is passing through this branch, it means the bridge is balanced. And when the bridge is balanced, what condition do we use? So we use P upon Q is equals to R upon S, right? So for the first part, in order to calculate this, we will use P upon Q is equals to R upon S. Why am I able to use this condition? Because no current is passing through this branch, correct? So when no current is passing through this branch, it means that the bridge is balanced, and when the bridge is balanced, it means P upon Q is equals to R upon S, right? So that is there. So you will easily find the value of S. Anyone can find this. I'll tell you the answers, don't worry about that. So my value for X, that is S which is equal to X, in this case it is given. So when you put in place of P, you will put 2, in place of Q, you will put 4, in place of R, you will put 3, and in place of S, you will put X. So the value of S or X is coming out to be 6 ohm. So that is, you will find out. I'm not going to find it out. Now in the second part, they are asking you to calculate current drawn by this circuit. How much current is drawn by this whole circuit? The second part of the question asks you to calculate current drawn by the circuit. So you have to find out that how much current is drawn by this whole circuit. So now this will not work. It doesn't have anything to take. So again this I is coming at this point. I1 goes there. Then what happens? Remaining I minus I1 goes here. At this junction, there will be no current passing through this because it is already given and the bridge is also managed. So the same I1 passes through this. Now this I minus I1 will comes to this junction. This is the first law, Kirchhoff's first law I am applying, okay, which was already in the questions of Kirchhoff's it was applied, but I am applying here. So now no current is coming, so no current will meet up, the same current will go there. How much will be the current? I minus I1. Now as you can see the same current is passing through this and this. So how they are connected? And this same current passing, how they are connected? I hope you understood they are connected in series, right? So you will take out the combination of these two in series. So P and Q, comma, R and S are connected in series. So you will take out the combination of this, I am calling it as RPQ, and the combination of this as RRS. Now the combination of these two will be connected in parallel, biparallel, because from the combination of P and Q, I1 is passing, and from the combination of R and S, I minus I1 is passing. So different currents are passing through, so therefore they are connected in parallel. And once you get this total resistance of this circuit, there is one more resistor which is getting there. Okay, so let me name it as small r. So whatever total resistance will come, that will be added to this r in order to find the total resistance. So that will give you the total value of total resistance. So total resistance will be equal to the parallel of these two, and this will be series, this will be series, combination of these two connected in parallel. Whatever comes, that will be added to this R. So R plus combination of these two in parallel, right? So that will come here. So total resistance is this. Total EMF or voltage is given 6 volt, and I have to find the current drawn by the circuit. So that will be E is equals to IR, Ohm's law. So I is equals to E upon R. So this you will calculate from here. E is given. So let me tell you the answer now. So the final answer has to be 1 ampere. I is equals to 1 ampere will be the current. Have a look and just understand how to do this part, and answers will be this much, right? Thank you.